The only thing we need to talk about now are limits at infinity, and it's also known as the end behavior of functions. So you may not realize this, but we actually talked about this somewhat in college algebra. There are only three possibilities for what can happen to a function's y values as the x values approach infinity or negative infinity. And those three things are: the y values can be going to infinity or negative infinity, such as this, like in the graph of a cubic function. As the x's get towards negative infinity, so do the y's. As the x's get towards positive infinity, so do the y's. Or the y values can be approaching 0 because there's a horizontal asymptote at 0. We saw that in a lot of the graphs we did earlier. As the x's get towards negative infinity, what's happening to the y's? They're heading towards 0. Over here, they're heading towards 0 as well. Or the y values can be approaching another real number because of a horizontal asymptote somewhere other than 0. Those are the only options. If you've got a horizontal asymptote, as you approach negative infinity or positive infinity, then your limit is going to be the horizontal asymptote. But if you don't have a horizontal asymptote as you approach infinity or negative infinity, your limit is going to be infinity or negative infinity. Really easy. You're not going to have any trouble with it at all. Now, I just kind of want to make sure that we go back over horizontal asymptotes one more time, even though I think we've talked about it already, right? Okay. If the highest power of the numerator is greater than the highest power of the denominator, then we say the limit does not exist because it is either infinity or negative infinity. When the highest power is in the numerator, there is no horizontal asymptote. Do you guys understand that? And because of that, the limit as you approach infinity or negative infinity has to be infinity or negative infinity because there's no horizontal asymptote holding it down to a specified y value. If the highest power is in the denominator, there is a horizontal asymptote at y equals 0, and the limit as you approach infinity or negative infinity also has to be 0. But if the highest power is the same in the top and bottom, then there's a horizontal asymptote at y equals a over b, right? Which is the quotient of the coefficients of the highest powers. And that means that your limits at infinity will also be a over b because that's what the function's y values are doing as the x's get really big or really small. So just to be clear, let's find the horizontal asymptotes for the function f of x equals 3 minus 5x squared over 2x squared minus 3x plus 1. So before we even find the limit, let's just make sure that we understand how to find the horizontal asymptote. Where's the highest power? It's the same in the top and bottom, right? So that means that there's a horizontal asymptote at y equals the quotient of those two coefficients, negative 5 over positive 2. So horizontal asymptotes only affect limits at infinity and negative infinity. They don't have anything to do with the middle of the graph. The only time you worry about a horizontal asymptote is if someone asks you to find the limit as x approaches infinity or as x approaches negative infinity. Other than that, horizontal asymptotes do not affect limits. They do not affect continuity at all. How about this guy? Y equals 4x cubed plus 2x minus 3 over 2x squared minus 9. Does it have a horizontal asymptote?
No.
Why not?
Because the highest power is on top.
Highest power is on top. Perfect. I don't know if you remember this or not, but it does have a slant asymptote because the highest power on top is one more than the power on bottom. But we're not going to get into slant asymptotes today. So for this problem, we have y equals 2x squared plus 3x minus 1 all over 5x to the fourth. And because the highest power is in the denominator, that means there is a horizontal asymptote at y equals 0. Do you guys know why?
Because the higher one's in the denominator.
Well, true. Because I told you it was true. If you look at it this way, the highest power is the same in top and bottom. And what are the quotient of the coefficients?
0 over 5.
That's why. Because when the highest power is in the bottom, it's the same as having a 0x to that power in the top. And that's why it pulls the horizontal asymptote to 0. This was the one I promised you earlier we would talk about today. What if we have y equals 4x minus 2 all over the square root of 9x squared minus 3x plus 1? In the case that you have a square root, like in one of your problems, you do have to take into account what the square root does to the highest power, but only the highest power. So what we do is we say the highest power on top is the 4x, and on bottom, if I take the square root of just the highest term, 9x squared, I really get plus or minus 3x. Do you guys agree with that?
Yeah.
So that's all that matters, are the two terms of the highest power. So you have to think about what the square root does to that highest power. And then you just look at it and you say that if I look at it that way, the highest power is the same on top and bottom, and this guy actually has two horizontal asymptotes, one at 4/3 and one at
Negative 4.
-4/3. So it is possible to have two horizontal asymptotes, but it is rather rare.